everyone, nice to see you again in Calculus 2. So today we're going to talk about integration by bars. So guys, you remember last time we were talking about U substitution. Today we're going to talk about something a little more difficult. What do I mean by integration by bars? First, let me remind you of something about derivatives. You remember derivatives? What is the product rule in derivatives? Can any one of you guys remind me what is the product rule? Ah, good for you. Remember, if I have two functions, f multiplied by j, and I want to find the derivative, how can I write it? Prime. It's written as f prime g plus f g prime. Good job. So, you know what? Maybe instead of f and g, I have other two functions. Usually in integration by bars, I use the functions u and v. And imagine now I want to find the product rule for these two functions. What should I write? Again, I have to write u prime v plus u v prime. How this will help me? Take a look at this rule again. And let's see. I have here u prime v equals to what? Can you write everything on the right hand side right now? Sure, you will say I have u times v derivative minus u v prime. So take a look at this rule. Now imagine I want to take the antiderivative for both sides. What should I do? Clearly, I will find antiderivative for the left-hand side and for the right-hand side. So imagine I have this integration, which is integration of u prime v equals to what? Let me find this guy on the right-hand side. As you can see, I have integration and I have derivative, and clearly they will cancel each other, so I just have this product u times v minus. And as you can see, this integration is for both of these terms, for this guy and for that guy. So I have to write minus the integration of u v prime. As you can see, here I have a formula. And actually, this formula is what I call it integration by bars. So interesting, right? Now the question is, how can I apply this formula when I have some difficult integration which I cannot use U substitution to solve it? Maybe it's better to give you an example so you understand what do I mean. For an example, I have the following integration for x and e to the power of x, and don't forget dx here. And I want to find the antiderivative of this function. As you can see, I have product here between this x and this exponential function. The problem is that we don't have direct answer. If you want to use U substitution, it won't work, and I'm going to leave it to you. Maybe you can give it a try using U substitution. But how can I apply the formula I already have here? So let's take a look. One of these guys, we're going to look at it as v, and one of these guys, we're going to look at it as u prime. If you suggest that x will play the role of u prime, then what is u in this case? If x equals u prime, then u will be what? The antiderivative of x is what? X squared over 2. Doesn't look nice, right? Because here I have linear function and it turned out to become quadratic function. What if I assume that this exponential function e to x equals u prime? We are just trying to see what can happen in this case. Imagine that this guy is just u prime. What is u in this case? As you can see, u is exactly the same with t to the power of x. So, what about this x? If I assume this x is v, then I have to find what is v prime. What is v prime, guys? The derivative of x is 1. Can I apply the formula I have on my right here. Let's try to apply it and let's see what we can have in this case. The formula says, take the product u times v. What is u? E to the power of x. What is v? It's x itself. So let's write both of them together here. This is u times v. This is u and this is v multiplied by each other. Minus integration of what? U v prime. So let's write our u, but u again is e to the power of x, and v prime is 1. So let's write 1. And since we are doing our integration, we must write dx as it, right guys? Right. So what we can have in this case, as you can see, I have this product minus, what is the antiderivative of e to the power of x? Yeah, it's the same function. And as you know, since we are doing our indefinite integration, don't forget your arbitrary constant at the end, which is plus c. Can I check that this is the real answer I'm looking for or not? Of course, you can check by taking the derivative of this guy. How? Take the product rule here. And let's check what we're gonna have if we take the product rule. I have two functions multiplied by each other. The derivative of x is 1 multiplied by the secant, plus x multiplied by the derivative of the secant, which is the function itself, minus, what is the derivative of e to x? Again, the function itself. What is the derivative of the arbitrary constant? Of course, it's 0. Simplify it. How can we simplify it? As you can see, the last term and the first term, they will cancel each other, and at the end I will have my original function x e to the power of x. So this is the real function I was looking for. Yeah. So that was one application of integration by parts. As you can see, it's so easy. But maybe you can take another example to make it more clear for you. Maybe I can clear this area to give you another example, not by exponential function, but by sine and cosine functions. So if it's okay for you, I can clean it right now. Okay.